Hello, my friends, and welcome to this episode of the AI Show. I'm so glad to be back. I was out of town last week in the UK. What a lovely place. Not only did I go there with tons of expectations and excitement, I came away with a cold. So if I sound different, that's the reason why. I have like a deeper radio voice, like, hello, everybody. I'm not even using my deep voice button. This is just my I'm almost over a cold button. Welcome. I'm pretty excited today. We have a good show for you. For those of you that are new, sometimes in our AI show, I'll just tell you. Sometimes we pre-record stuff and then we play it. Not today, my friends. Not today. We're doing it live. We're doing it live. And so Alicia's here to talk about fine-tuning. Yeah. So where's everybody coming from, my friends? Just tell us in the chat here, wherever you're coming. I multi-stream this to many places. And so just tell us in the chat. If I'm looking over here, I'm looking at what you're saying. Just a side eye. Just a side eye. England. Surly. Oh, I know Surly Deb. Hello, my friend. Just side eye. Where are you coming from? And if I sound different, this is Seth again. Not only did I go to the UK for the wonderful cuisine and company, I came away with a lovely gift. But don't worry. I checked myself for COVID. I'm fine. Nobody's going to get sick here because this is on the computer. Okay? This is on the computer. Look, these are the jokes, okay? So let me share my screen and tell you what we're doing today. Oh my gosh, I was such a baby yesterday. I was like, I don't feel good. Still don't feel good. So we're not going to know. You're not going to know like what kind of show this is when you get Seth is almost over being sick. But number one, most important thing is we're going to be talking about fine-tuning. Fine-tuning. Everyone keeps asking me about it all the time. Like, seriously, all the time. They're like, hey, I need to fine-tune my model. I'm like, are you sure? And so Alicia is actually going to disabuse me of any false notions that I have and hopefully corresponding, as well as yourselves, remove any false notions we have about fine-tuning. When it's full, what it's for, what it's useful, etc. All right, so where's everybody coming from? Let's see here. We have folks from Oregon, Poland, the UK. Hello, Stephen. Mark from Oregon, even though his name is Frank. Hold on. You need to see this here. I need to show you this. Hold on. Hold on. Where is this one? Let me find it. Is this confusing? Or is your name like Mark Frank or Frank Mark? I don't know. Yes, Shirley Dev, I was in the UK just last week for Envision and the Build AI Day. It was glorious. Someone from Carnation. Lovely. Hey, I just live north of there. If you go up the road, there's another town just north of. I'm not telling you where I live. Some of you people are crazy. Israel. Hello, Limor. Terrible situation over there. I don't like it at all. C# Fritz is in London for a short time as all that trip to... Okay, that's... Oh, hold on. Jenny student number 7. Welcome. Hello, Marina. Lurie from the EU. Seth, how do you fine-tune when hand is paper and not Spock? Oh, that's a great question. Not sure. By the way, Janice student number 7... he always goes to our Twitch place. So there's like 3 people there. So he's like, hello? What? Am I the only one here? Oh, look at this. Someone else. This is cool. You got a cold. I went ham on my wrist and got carpal tunnel injury. Yeah, stretch. Let's just maybe... All right, so I'll lower the music down there. And number two, what we're going to do is we're going to answer questions. Answer questions. So for part of the show, it's going to look like we're like literally live studio audiencing this thing, and so that's why it's going to look a little weird because you're going to see like how I cut these things together when we pre-record them. And Alicia's a pro, so I wouldn't worry about that. We have India. He's called Mark from Oregon, and his letters get franked with those numbers. They look like oh, interesting. That's cool. Catholics get multiple names. Oh, so here we go. Get multiple names like Marcus Franciscus. Mexicans do too. I'm Mexican. My full name in Spanish in Mexico, because you get, if you get a middle name, that means you get four names. Four names. I forgot to turn in my music box. Look at this. My sick brain is just not working. You get four names. Like, so my name in Spanish is Seth Abram Juarez Estrada. Yeah. How exciting is that? Oh, so Filipinos get four names too. Power to us brown people with all the extra names. Other people are missing out. When you get yelled at by your mom and they throw their shoe at you, you don't know if they use all four names. You better run for the hills. You are in terrible trouble. Janice Q number 7 has 3. Okay. All right. So that's enough of my dumbness. So let me remove this and let's invite Alicia. Alicia, you ready to chat? Thumbs up. All right. How you doing, Alicia?
I'm good. I'm excited to talk about fine tuning.
Oh, I know. I am too. Like, here, sorry, I got to turn this on. I have so many people asking me about this stuff that like I feel like it's time that we actually like talked about it in a clear way. I mean, do you get a lot of questions about this stuff? I'm sure you do.
I am currently ignoring like 45 unread Teams messages that I think if I opened, most of them would be like, is this a use case for fine tuning?
And so we're gonna do this. So we're gonna do this show. Let me make sure my yeah. So my other sound is working. Okay, good. So we're gonna do this show. Surly Dev is saying, "Do not open them."
I am ignoring them for all of you right now.
That's right. They are a trap. They are a trap. I just got one from our from one of our people, and they're like, "Hey, I don't want to open it. It starts with we have an EBC session this morning." And I'm like, oh no, I don't want to get people sick. So now I'm going to say I'm sick for the rest of my life. That way, I'll be like, I can't go to your thing.
Great plan.
Because it gets sick. Okay, so we're going to start this show. Just for your information, a couple of instructions. Try to look at the camera the whole time. If you run out of things to say, just stop talking. I'm going to do like a little intro bit. We cut that out sometimes and put it into social media, so it'll be real quick. Any questions for me? Is this the right title? This is the right title, right?
Yeah, sure.
Did I spell your name right?
You did. That I would have told you a while before if you had spelled it wrong, or I wouldn't have and just renamed myself.
No. We don't do that. But it's cool that your last name is Frame, because if your middle name was Data, is your middle name Data? Because you would be Alicia Data Frame, which is the perfect data science name.
Yeah, they named data frames after me.
That's what I thought. I was going to ask, and now that we know, everybody, this is Alicia. They named data frames after her. So thank you to her, we all have data science. Otherwise, we wouldn't have it, right? All right, you ready?
Yep.
All right, here we go. So just look straight at screen. You're not going to want to miss this episode of the AI Show where we talk all about fine tuning with Alicia Frame. Make sure you tune in. Hello and welcome to this episode of the AI Show where we're talking all about fine-tuning, to fine-tune or not to fine-tune. That is indeed a question with Alicia. Alicia, how you doing, my friend?
I'm good. How are you?
Fantastic. So I thought am I hearing music?
I'm not.
Why am I hearing music? Where's that coming from? Oh, my goodness. So we gotta do that part again. I think is it me hearing are you hearing stuff? Where is that coming from? Hold on. Oh, so, looks like they are hearing music on their end too, so let me s that is weird. Who is playing music on my stream? Hold on one second. Let me take a look here. Yeah, so you're not hearing music, Alicia, but, is Carol's our producer in the back end. Carol, are you hearing that? Just, give me a not hearing. It's just nope, everyone's saying they're not hearing it here. So where's that coming from? That is so weird. I have, like, some phantom here, I'm gonna turn Teams off. Maybe that's doing it. One second. Nope, not Teams. Turn this off. Oh, I'm so dumb. I had YouTube opened with my home stream.
That's fine.
Oh, we're professionals
It's
here.
still early.
Hold on. Someone has the quote of the day here. Hold on, I gotta find it. Here, it's in the chat. Hold on. Hallucinations. Hold on. So, okay, you didn't hear it, but I heard it. It's okay. We're all good. We're all good. So let me. Okay. All right. So we got to do that part again. I'm sorry. It started so good. We sounded so profesh. But I got to do it again. All right. You ready?
Go for it.
You're not going to want to miss this episode of the AI Show where we talk all about fine tuning with Alicia Frame. Make sure you tune in. Hello, and welcome to this episode of the AI Show. Where we're talking all about fine tuning to fine or not to fine tune. That is the question with Alicia Frame. How you doing, my friend? Why don't you tell us who you are and what you do?
I'm good. I'm Alicia Frame. I'm the product manager for Azure OpenAI service, looking after fine tuning. So all day, every day, fine tuning.
That is amazing. So listen, I get this question all the time, but I thought we'd go through each little step so folks get a clear understanding of what it is and maybe how to do it. But let's just start off with what is fine tuning as compared to other things?
So fine tuning is a way of customizing a large language model. But there are other ways, and I think this is kind of where people sometimes get confused. And the way that I think of it as your fine tuning is one way to customize. If you want to add your data, there's kind of two tracks. One is adding information into your prompt, which is information that you're giving to the model to answer a question. The other track is changing the model itself. And so RAG, prompt engineering, retrieval based techniques, those all mess with your prompt. Fine tuning is actually retraining the model, changing the weights of the model to make it perform differently, to teach it a new skill, to teach it new information, to change how it acts.
I see. So when we say add your data, to actually do LLM. It's a little confusing because for some reason a lot of people are saying that is that training adding different weights to the model, and so that's not the case. You're doing a prompt thing, but you can also do a fine tuning thing. Did I get that right?
Yeah, I think like the brand name add your data can be a little confusing for folks because in that case what we're talking about is adding your data to the prompt.
Got it.
Fine tuning is adding your data to the model, and it operates differently. It has different outcomes. So two different tracks, both customize your model, and in the end you probably need both of them together.
Oh, interesting. So here's a question though, because I have been going around, and if I'm wrong, you throw the flag at me. I've been going around saying that for the majority of use cases, it's probably enough to fix your prompt and then send it to the LLM. So the question that I have for you is when is it appropriate to use fine tuning, and is that statement that I made correct?
Your statement is usually correct.
Okay,
So, like most of the time, you can get what you need with prompt engineering. You can add more information into your prompt, you can add few shot examples and get the outcome you want. And no matter what, I would always recommend you want to start with prompt engineering because you want to know how far you can get with the base model with prompt engineering so you know if fine tuning is actually making it any better or not. kind of when fine tuning comes in and when you make the choice of like, oh, I really do need to fine tune here, is kind of two different areas. One is you need to teach the model a new skill. So you want the model to just do one thing, but do it really, really well. And it's not really able to do it without a lot of guidance. Or you want to kind of change the behavior of the model. And I'll show this in a demo.
Okay.
The other case when you might choose to fine tune is if you want to lower your latency, use a cheaper model where you want to switch out one model for another. So instead of GPT-4, use fine tuned 3.5 Turbo. Or, hey, you've written a beautiful prompt, but it's really, really long. It's causing a lot of latency. And you want to move a lot of those instructions directly into the model, reduce latency, reduce inference costs. That's another use case for fine tuning.
I see. So it feels like if you want to, because these models are super general, but if you want to narrow the scope of the model a little bit, if that's kind of like usually that there's like a smell, a code smell when I was a dev, that's what is that a good smell to be like, if I want to narrow it, or am I
Yeah.
off a little bit?
No, that's like a really good example of like, so GPT-4 does a lot of things super, super well, but maybe all I need is a model that classifies things according to my rules quickly and at a low cost.
I see.
And GPT-4 is overkill for that. I can train Turbo using a fine tuning data set to just do that one thing and do it well. So, kind of that go from broad generalist model to single skill is a really good, like, maybe fine tuning for this one.
Got it. And the other thing you said is that if you find that your prompt is overflowing a little bit, because I mean, like there's only a certain amount of space in the prompts, that's another good indication that maybe it's appropriate to fine tune.
Yeah, sometimes you'll hear people talk about fine tuning and they'll say fine tune when you want to show not tell the model what to do. And this is like you have a lot of edge cases, a lot of examples, and you're starting with prompt engineering and you like add example 1 and you're like, not quite, add example 2, still not there, and you keep adding and then you run out of space. There's too many edge cases, too many behaviors where you're trying to show the model what to do. And that's a good like, oh, fine tuning, move those instructions into the model. So you see that a lot with like natural language to SQL use cases, or like classic example is like teaching the model to play chess. It's kind of these, I can give you 1,000 examples of what I want you to do, but I have trouble verbalizing that in, a few hundred characters.
That makes sense. And so let's talk a little bit about how it's done, because like I'm kind of a data scientist, not as much as you, but my sense is that these models are so big. Are you fine tuning the entire model, or
No.
what is it that's actually going on? So people get a sense for that.
So we do not offer full fine tuning. There are a lot one there's a when we say fine tuning means a lot of different things.
Right.
What we offer on Azure OpenAI is supervised fine tuning. And the way we go about that is LoRa, or low rank approximation. And so with LoRa fine tuning, you're really only adjusting a very small subset of the weights for your use case. You're not going in and retraining the model from scratch. This makes it a lot more cost efficient, a lot easier to deploy. Lots of optimizations involved in doing that.
I see. So you're basically optimizing a subset of the internal model weights with your particular data. That way, it learns new pathways, etc. And that's what's going on.
Yeah, and I think that goes back to there's many types of fine tuning. Supervised fine tuning is kind of example based. So you provide the model with like, here's the input and here's the output I expect. And you provide it, hundreds, hopefully thousands of examples of that. And that's how you train the model, fully supervised. Other techniques, continual pre-training, RLHF operate differently, but for this it's very much around teaching the model to do one thing well.
So, and now this is, I remember when I was doing my research, in computational linguistics, there was this theory called pack learning theory that taught us how many examples we needed to give the model for it to be successful. Is there something like, is my sense is that that's not the case for these models?
No. So the rule of thumb, one is the pipeline will fail if you have fewer than 10 examples.
Yeah.
It'll just error out. That does not mean 10 is enough. 10 is not enough. My experience is like more is always better. The more sophisticated the model, the fewer examples you tend to need. So, like, I have fine tuned GPT-4 versus 3.5 Turbo versus Babbage and DaVinci.
Hmm.
Smarter model, fewer examples. Complexity of the task at hand also requires kind of different numbers of examples, but there's no like, you want to teach it NL to SQL, that requires 257 examples for 3.5 Turbo. You're basically, what you're going to do is get together a good sized data set, fine tune, evaluate, and iterate. And I have a demo later on where I'll show you kind of fine tuning two different models to do the same thing. But one of those models takes a lot more data to get something vaguely plausible than the other.
Okay, and then the last question before we go to like, can you show us how it works? When the model is fine tuned, I work with a lot of enterprises, and I talk to like their risk people and their other people. When folks are fine tuning the model, is it fine tuning like an aggregate model that everyone has access to, or is it like completely private to the user? And I think I know the answer to this, but I want to let you weigh in on it.
Private to the user. So
Okay.
when you fine tune your model, it is all in your own secure workspace. We don't have access to your data, to your weights, to any of that. When you finish fine tuning, what you get is basically the new weights for inferencing using your customized model, using your data. And when you deploy that, what you're deploying are your new weights. So you have your own custom model that is in its own secure environment. It's isolated. You're not like sharing your secret sauce with everybody else.
Yeah, that makes sense. And then I thought I was alive, but then the other one just came into my head. I I've been telling folks that content safety is built into all Azure OpenAI things, and that traps, things coming in and going out to make sure that it's blocking things that are sensitive across 5 different areas. Is that still the case once you fine tune the model? Can you tell us about that?
It's super important for fine tuning. So it
Yeah.
is definitely still the case. One of the risks that you've probably heard about if you've like Googled fine tuning, read articles about it, is a lot of people are concerned that fine tuning can inadvertently fine tune out safety, or a bad actor could fine tune a model to be evil. And we don't want to help people do that. We don't want
Yeah.
to condone that. So content safety is applied, to all of the outputs from your model. You have the same moderation to make sure that nothing is unsafe or harmful, and that you're only getting the good stuff.
Awesome. Well, I thought now that you've given us all the details, can you show us how this is done? People can get a sense for what the data looks like, what the process looks like.
Yep, let me share my screen. Give me 1 second.
And this is the part, for those that are watching, that I edit this part out. So now I can make all sorts of weird hand signals and it won't show up in the official one. So okay, so let's see. Okay, cool. Stand
So
by.
now
Oh,
you can.
hold on, wait. Then what you'll do is just start here, you see, and then we'll go from there.
Okay, so here you see the Azure OpenAI Studio. It's a really easy place to get started using Azure OpenAI, and I'm going to use this as a UI to demonstrate kind of what fine tuning looks like, the workflow. Just an important caveat is this is also all possible using our APIs, the Python SDK. It's just a little more boring to watch me hit run in a
So let's
GPU.
pause right here before we got to do this for again. So you see where it says at the bottom, it says hide. Make sure you hide that of your screen. It says restream is so hide. Nice. And then control plus for me twice. Control plus just to make it bigger.
Better or even more
One more.
bigger.
There you go. And then you want to turn off Teams too.
Teams is turned off. I'm going to switch to actually just sharing a window.
Okay. Because it's
Sorry
all
about
going to be in the
that.
same window, right?
I will switch to Visual Studio at one point, but it'll mostly be in this window.
Okay. Cool. So for those that are watching, this is when I record these things. Usually something like this happens right when we transition the screen. I usually cut this part out. You're just getting the bonus stuff. But there's some good questions in here, so make sure to keep them coming. Alicia will answer them at the end. All right.
So you
Oh,
can
wow. You
see,
look super clear now, Alicia.
and am I sharing the right window now?
You are. So just start with, so here you see.
So here you see Azure OpenAI Studio. This is a super simple UI for interacting with everything we offer on Azure OpenAI. It's also possible to do fine tuning via the REST API or the Python SDK. It's just not as interesting to watch for a demo.
Right.
So what I'm going to walk through is just fine tuning, kind of cooking show demo style. So I want to fine tune. I go to models. And you do have to be in a region that supports fine tuning. So North Central US and Sweden Central.
Okay.
Uh, Fine tuning a model is actually super easy. So all I do is I click create a custom model. I choose the base model that I want. And for this, I'm going to choose 3.5 Turbo. So there's 3 models you can fine tune. Babbage and DaVinci are completion models, simple models, low cost options, not as capable. And then Turbo is a chat model. This is a more general purpose model, more sophisticated. You do have to provide chat format data. But for this, I'm going to just choose Turbo. I'm going to call it Cool Demo.
Nice.
And great names. Next thing I do is I'm going to choose a data set. You can upload a data set. I happen to have a bunch of stuff already loaded. So I'm going to choose a data set, emoji training. I will talk through what I'm actually doing once we kick off running. So choose a training data set, choose a validation data set. This is actually optional. You don't have to provide it, but it makes it much easier to tell if fine tuning made the model better or worse. Advanced options, this is kind of if you want to put your data science hat on. Right now, you can just change the number of epochs, which is basically how long will it take for me to fine tune my model. How many passes over the data do I do? I don't want to change that. So then I can review. I see base model, training, validation file, and actually kicking off training is as simple as start training job.
So before you go, we keep going. I thought I'd ask a couple of questions. If you see me looking at the side, I'm looking at the screen here. So there was a couple of different model options. Is it written down anywhere when you should use which?
So it's written down in our docs. The kind of rule of thumb is Babbage and DaVinci are completion models. So, like, given a phrase, what's the next phrase? What's the next word? Turbo is a chat model. So it's a conversational interaction. So I could say, hey, what did you think of the demo? And it would respond with an answer instead of the next most likely word.
I see. And so it's the use case that makes a difference. But what about the size? Are the sizes equivalent? I know we don't know much about some of the models, but are the sizes the same? Does that really change what you decide to do?
So Babbage and DaVinci are GPT-3 base models. If folks have fine-tuned with us before, we used to offer Ada, Babbage, Curie, and DaVinci O1 as fine-tunable models, simple GPT-3 based completion models. Now we offer Babbage 002 and DaVinci 002, next generation of the same models. They are smaller. We don't say exactly how big they are, but they are smaller models relative to Turbo.
And the next question I have is regarding the data. What does the data look like?
So let me share my data, or let me share what the data looks like. Uh, so here is a sample of the data. And so this is where I said I was going to explain what I'm actually doing with fine tuning.
Okay.
So for this example, what I'm doing is we talked about I want to teach the model a new skill.
Mhm.
And so the skill I want to teach my model, and we can argue if this is a skill or not, is to only respond to my input with an appropriate emoji formatted as it would be formatted in Teams. So if we take a look at this, you've got kind of an example data set for a turbo model. So this is chat formatted. So what you have is you have the input, the system message. So you're a chatbot, you only respond with emojis. And then I have my input message of I just passed my driving test. And then what I would consider the appropriate emoji response. In this case, it's party, and it's formatted in the like parentheses emoji name because that's kind of how Microsoft recognizes emojis in Teams, and that's how I
Got it.
generated my data set. And for this, what you can see is I've got, I think this file might have 600 examples, but they're all formatted as uh, prompt and response.
I see. And it's actually in the same format that you would like it's the same thing you would post to the service effectively.
Exactly. It's exactly the same. And then so if you look at like the same file formatted for a model like Babbage or Da Vinci, this probably looks familiar to you in terms of prompt completion format, right? You
Yeah.
have prompt and then you complete it with this emoji. Um, and you do need a stop character.
That's amazing. It's actually simpler than I had envisioned. But I people keep telling me that this stuff is harder than it is, but this is really simple. So why is it hard to do this if it's this easy to set up?
So it's deceptively easy to set up.
Okay,
Where it gets hard is if you mess up your data, you will still get a fine-tuned model. It'll just be terrible. So when we go back to kind of the cooking show and we look at the models that have been fine-tuned, I have an example where I took my fine-tuning training set, right? Where we have the appropriate response, I passed my driving test, party, and I basically knocked the responses off by one. So the responses no longer make a ton of sense. So we have I passed my driving test, and what is the response? It is poop. Um,
oops.
we can still fine tune a model with this. We'll still get an output, but you'll see bad data in equals bad fine tuned model. So
I see.
it's not like the act of fine tuning itself is hard. What's hard is getting the right data to make the model better and not worse.
Awesome. So can we go to the baking show? Because obviously, when you're getting to this other part and you're going to bring up your screen, another question I have for you is how long does this take? Because my sense is that it would be a pretty boring show if we said start fine tuning and we all just put like elevator music on.
Yeah, we're not going to sit here and watch it. So we can see what we see here is I have all this is the job I kicked off before. It's pending. We can check on it and see what it's doing. Training started, but it's probably going to be, I don't know, an hour and a half until that one finishes. So that would
Got
be
it.
really boring. We can take a look at one that I did earlier. And so when your job is finished, you'll see succeeded, and we can click on it, and you'll get some metrics about how did fine tuning go. So we can see over time, training loss went down. I can see training token accuracy. This one takes a while to plot sometimes. So
Hmm.
let's switch to loss. You can get some basic statistics about how did it go. And then I can see, okay, this took 1.25 hours to train. So this is the example data set we were just looking at. And I can see kind of all the different steps. It had to retry a couple times, but then it finished and then my model was available. And so if I want to go check out my model, I just go over to deployments. And you can see these are all the models that I have fine tuned and some base models that I already deployed. I just click create a new deployment, and creating a new deployment basically makes that model available to inference against.
I see.
I choose a model, and so I've got my base models at the top, and then at the bottom, all the fine tuned models I've already set up show up. So I'm going to choose one that I don't already have deployed. Um, and then I can call it demo deployment. And what'll happen is, assuming I haven't run out of quota, you'll see it under the deployment list, and eventually it'll deploy. This usually takes about 5-10 minutes to be deployed. And then once it's deployed, we can go interact with that model and kind of see how it responds.
And you can interact with a model in the playground just like you would any other model.
Yep, just like you would with the base model.
That's
So,
awesome. Okay. So in my mind, if I want to distill down the process, the first thing is, and I know I want to see you play with it too. The first thing is you got to gather some data. It's got to be appropriately shaped for the type of model, whether completion or chat. Once you start the fine tuning job, you got to wait for an hour or wherever, however long your data set is. You've got to look at metrics, make sure it's done the right thing, because if it's diverging on the loss, then we have a problem. You don't want to use that model. And then you have to deploy that model as a last step. Did I get that right?
yep. And then maybe one step after
Okay,
of now you've deployed your model. Now let's talk to the model and see if it's better or worse.
let's do it.
Okay, so this is a deployment I set up earlier. And if any of you have used AI Studio before. This is kind of what it looks like. I've got my assistant set up on the side. I've got my chat session, and I've got my configuration where I can toggle between different base models. And so what I have here is I have Turbo, which is just the off-the-shelf, unfine-tuned model. I have my fine-tuned emoji chatbot model, which we have fine-tuned to respond with an appropriate emoji. And then we have our bad emoji bot, where we've chosen a dubious data set to fine-tune.
Nice.
So let's start with Turbo. And this is the system message that was in the fine-tuning data set. You're a chatbot, you only respond with emojis. And this is what it does with kind of no guidance whatsoever. And you can see this is not the format I want, but it does respond to emojis. So how do you feel about fine-tuning? I don't know what that means, but this is how Turbo feels about it. So this is the base model. Now what we're going to do is we're going to switch to the fine-tuned model with the data set that we just looked at. So this is emoji chatbot. I'm going to cut down the number of messages in the past that are included, and we have the same system message as before. So that's important. If you don't have the system message used in fine-tuning, you won't get your expected response. But now let's all cross our fingers because this is live and see how it responds. Voila, it is responding in my appropriately formatted message. I've changed the behavior of the model, right? It now knows to respond in a different way, and it is responding mostly appropriately. So let's try. How do you feel about fine-tuning? Okay.
Nice.
It feels a little bit about it. Fine.
Yeah.
Okay. So it is responding in the right format, but these could be better responses. So let's try the bad emoji bot. And this one has been trained with garbled data. So you could say, this generally makes sense. If I say hello, it says wave. Cool. Let's go to bad emoji bot. And this one, let's see. Try hello again. Thank you.
Oh man, that's awesome.
And so this is like the data looked fine, right? But now it's pretty garbled. Are you okay? This is not a good model, right? What might that mean? So we garbled our data set. We've made the model worse. So it's pretty easy to accidentally make your model worse.
I see. And it may even be a situation, and now I understand why the last step is to actually try it out. It may even be that the last step, if you don't do the last step, which is test it, that your loss will look good, your validation loss will look good, but it's still not the right thing.
So I think we can probably actually go in and look at the evaluation on this model.
Let's do it.
Let's see. The only problem is it's a little... Okay, so here's bad emoji bot. This looks fine. Like,
yeah.
There's nothing that makes me say like, oh, something has gone horribly wrong here. This looks fine. It's only when you go to talk to the model and it just says poop that you're like, oh no, something has gone wrong.
Well, this is awesome, Alicia. We're kind of almost out of time. Where can people go to find out more?
So I think I shared some links ahead of time. Let me stop sharing my screen. The easiest place to go is in our docs. We have a tutorial and a how-to guide that show you how to get started with some nice, easy to follow examples. They are toy examples. So 10 examples. It shows you the process.
Right.
And we've got a blog outlining it, and really just get your hands dirty and find out how it works.
That's amazing. So I put the links below. I short linked them for us. So they can be the tutorial you can find here. Make sure you go take a look at that. And then the blog is here also. For if you're interested in the Azure OpenAI service, there you can go take a look at that right here. And then finally, if you want to sign up, you can do that here. Well, anything else that you want to add to finish up?
So the one thing that I didn't show, but I do have a demo of, is you can also fine tune a smaller model to have the same behavior as the bigger model. So the demo I showed was using Turbo. It's an expensive model to fine tune, expensive to deploy, comparatively expensive for inference. With a sufficient data set, I can actually fine tune Babbage or DaVinci to have that same behavior of just do one thing really well, and all it'll respond with is your kind of completion emoji. But it's that idea of if you take a less sophisticated model, but it only does one thing, totally feasible and a great use case for fine tuning.
Well, that's awesome. We should hopefully that's in the is that in the blog that people can take a look at?
It's not, but I should write a separate blog about it.
We'll make sure to point that, and if not, we can have you back on and we can take a look at that in more detail because this is awesome. Thank you so much for spending some time with us, Alicia.
Thank you for having me.
Awesome. Thank you so much for watching, my friends. We're learning all about fine tuning, to fine tune or not to fine tune. That is the question here on the AI Show. Thank you so much for watching, and hopefully we'll see you next time. Take care. Alrighty, friends. That was the official. That's how we make shows behind the scenes. All right. So there's some questions that I want to go through here, if that's okay. Hopefully you've been looking at the questions. Oh, here's a good question from Kandasamy Muthusamy. Is the content safety applied to the training data?
Not right now. So we have the kind of, if you think about the Azure philosophy for interacting with customer data, we don't want to go into your data. Your data is your data, it's private, we don't have access to it. You can supply whatever you want as fine tuning training data. We moderate the output. This is a little different than how some other services do it, but
Mhm.
we only moderate the output. So same result, you can't make your murder bot or your evil chat bot, but we just stop you kind of on the output instead of the inputs.
And that makes sense because if we did do that, we'd have to like do stuff with your data that we just don't want to do.
The
Right?
user experience would be weird, right? Like,
Yeah.
hey, why did you train your model to only respond with the poop emoji? Like, we just filter on the output.
And the reason why is because Seth has a 12-year-old brain, and that's what he wants to respond with every chat. But he's going to use a giant model to do that instead of just
Yeah.
All right. So here's another question from Dimitri. Let me make sure. Oh, it just moved. Ugh, I'm so dumb. I keep moving here. Let me turn this up. Hold on one second. What? There we go. Sorry, I like music in the background because there was another one from Dimitri. I gotta find it. It's when will Azure OpenAI Studio be available for developers and at what cost?
Azure OpenAI Studio is currently available. So if you sign up for Azure OpenAI, there's like a little form to sign up, basically to acknowledge the terms of service. But then Azure OpenAI Studio is already available. It's already there. You could get started today.
Oh, okay. Cool, cool, cool. Let's take a look at some of these other questions here. So that content question was awesome. There's so many people are posting. So here's one that I don't think we can answer. But when will fine tuning be available for GPT-4? Is that something you would want to fine tune though?
That one's a lot more complicated. It's a much more sophisticated model. There's some really good, actually, academic research papers into like the behaviors of a fine-tuned GPT-4 model. I will try to find the paper and drop it into the chat. Um, it's something that we're actively looking into and scoping, but we don't have a release date. Right now, the recommendation would be like if there's something that you cannot get Turbo to do with a combination of RAG, prompt engineering, and fine tuning, we'd love to hear about it. We talk about most people don't need fine tuning, and maybe 5% are going to fine tune. And then out of that 5%, 99% of them are probably going to be fine with Turbo. And then that tiny 1% is, future roadmap.
Okay. So is there any questions that I should have asked that maybe like the bonus episode here people get in the end? Is there something that I didn't ask that it's like, whoa, Seth, people should really know about this, but you didn't ask the question?
Oh goodness. I mean, there's a lot of stuff to know about fine tuning, which I forget most of the time.
Yeah.
Um, I think The one thing that is useful for people to know is if you want the model to know something that it doesn't know anything about. So, like, people will come and they'll say, so my background is biology. People will say, I want a biomedical chatbot. I want it to know about healthcare. I want it to know about drug discovery. Can I use fine tuning for that? Danger, danger. Fine tuning isn't, you're not really teaching the model new things. You're teaching the model different ways of responding kind of with what it already knows. So, like, the cases where you're like, I want to know I want the model to know something it's never seen before, that is not a fine tuning use case. That is RAG. So that's my big caution sign.
And that's important, right? Because I mean, you're probably more than me, but I get the question almost every day, like, how can I fine tune this model to do foo or bar or baz? And then in the confusion with vector databases, sometimes creeps in there. If I vectorize my data, is it easier to fine tune? No, that's not what this does at all. And so I get a lot of that, and I think once we explain these things, people pretty much get it. They're like, oh, okay, that makes sense. Are you finding that to be the case too?
I think, I have a couple like little cheat sheet tables that I use of like, if you're trying to do X, start with
Oh,
Y, and then it clicks. But I think if people don't walk through examples, it can seem very nebulous. And in the end, like a lot of these very fancy production models are a combination of RAG and fine tuning and prompt engineering and maybe retrieval from a vector database. I don't know.
right.
But you kind of put everything together for the best possible response versus like a magic bullet that solves everything.
CJ was like, CJ here in the chat is just like, my brain said the same thing, CJ. Ooh, hold on. I even have a sound effect for that. Hold on. Can you share that with us or is it in the blog post?
There's a text version of it in the blog post. It is coming to our docs this week. So it
Ah,
will be available soon. You all get a sneak peek.
so we're going to give you a high five and clapping for that. That's amazing. Here's another question from Cassie. Cassie's awesome, by the way. Sometimes she does the show too. She's the AI show too. Is there still a reason to fine tune older transformer models? I think you hit on that a little bit, but maybe give us a little bit more details on why one would do that.
So when you say older transformer models, are we talking about the like Ada Babbage
I think
period
what
of Vinci, or are we
yeah,
talking about like olden times before we were just talking about OpenAI models?
I don't know. Like I think she's saying transformer models. Maybe she can clarify, but transformer models are all basically the GPT series. I don't know. My
So
dumb brain thinks of transformers as like the new convolutions for language, but that's just my dumb brain, even though they're not the same thing. But go ahead.
so I think so what we offer now in public preview are Babbage 002 and DaVinci 002 as well as Turbo. You might choose Babbage and DaVinci 002 to fine tune because they're cheaper, faster. They often require a lot more data to fine tune to get
Right.
the output that you want. But cost savings can add up. So I can fine tune DaVinci to give me basically the same results as Turbo, but the cost to deploy DaVinci is less. Kind of if it's a narrow task. So I wasn't asking Turbo to do anything super exciting. It was just responding with emojis. Narrow task, you can use one of the simpler models. We have the old ABCD models, but those have been deprecated. So they are on a path to retirement, I think January 2024. And so if you were just starting on your fine tuning journey now, I probably wouldn't pick those up. But depending on your use case, if it's a completion use case, if it's simple, you may want one of the GPT-3 based models instead of Turbo.
I see. Because so in the sense because it's a cheaper model, and if you have a narrow use case, you may be able to be more cost effective by fine tuning the one for a narrower use case, is what you're saying.
Yeah. And it's worth noting, like if you just pick up Babbage 002 or DaVinci 002 and you kind of play around with it, the way I was playing around with the turbo based model in the playground, uh, the Babbage and DaVinci 002 models, their outputs are weird. You're like, these are terrible models. I don't want to use these. But when you fine tune them, you can fine tune them into something useful, correct for your use case. It's just more data, but at the end of the day, it is a significant cost savings.
Yeah. Here's another question. I'll answer this, and maybe you can help me out. I believe we can also fine tune the model deployed using prompt flow, or is it only done on top of the foundation model? Prompt flow doesn't create models; it just uses them. So in this case, and correct me if I'm wrong, is that you can like help me. I'm like the student here. You're a professor here. I'm explaining to you. So if essentially what you would do is you would still use the same model node, but you would point it to the fine-tuned deployed one. Is that right?
Exactly. So
Okay.
you could think of like, and this is where it gets kind of cool, like where it's like, oh, I only want the model to do something specific.
Right.
So you might have a prompt flow workflow where like you might have, input disambiguation and you're trying to figure out, is this a query about, I've seen your demos for like Contoso,
Yeah.
whatever. So you might be saying, is this a customer support request? Is this a like inventory check request? And
I
there
see.
you could use a fine-tuned model that's just fine-tuned to do one really specific thing, classify, and you could use that in your prompt flow workflow to classify what is the person trying to do. And in that case, use a simpler model. Um,
And that's clever because like I call that intent mapping. Because you could essentially train or fine tune a Da Vinci model to do intent completion on input.
so it's prompt flow creates kind of a cool way of stringing together. I have fine-tuned models for different purposes, endpoints, use cases, and you can point them at those and kind of get those specific behaviors in a very kind of natural workflow.
Yeah, and that I hadn't considered that. You could instead of making like your GPT-4 model do the whole thing, which is going to be expensive and take forever, you could essentially break up the language tasks into more narrow cases that then feed into the super model to do all the things.
Yeah, you can kind of have those narrow use cases and only pull out, GPT-4, the big guns, when you have the very complicated task.
Cool. Here's another question from Jason, and this is a question we get a lot, Jason. So it's not just you. Can you explain more about fine tuning versus embedding? Because these are separate things, right?
Yes. So this is like also going back to like previous jobs.
Right.
So embedding is really just coming up with like a low dimensional representation of a concept, of some data, of an input, versus fine tuning is kind of changing your model weights to get the output that you're looking for. Where the overlap is you may be tuning and embedding to get the output that you're looking for, but they're both techniques in the world of generative AI. Um, and I guess you could fine tune an embedding. We don't offer that like as an off the shelf service, super simple couple of clicks. But typically, embeddings are used for representing your inputs, whereas fine tuning is changing your model.
I see. Yeah, and I usually and I get this confusion a lot. Embeddings are super useful for prompt engineering, primarily because it allows you to scope down the size of the text that you're actually injecting into the prompt. And
Yep.
so when you're doing embeddings, you don't embed the entire document. You could, it would do it, but what you want to do is you want to chunk the document in such a way that the index returns exactly the data that's most similar to the input question, and then you can inject it in the prompt. But the models themselves do not take vectors. They don't do that. They take language, and that's the one thing that I have to disabuse people of. Alicia, your reaction to that?
Correct. I think like embeddings are great for reducing the dimensionality of your input, or if you're looking to like do retrieval, you can find something, in that's similar in the embedded space to your input text. So you get that answer in your RAG workflow. But in terms of what you pass into Turbo, Babbage, DaVinci, you're passing in text. And what is it emitting? It's emitting text.
Correct. Okay, cool. That's cool. So I got it right. Awesome. Here's another question from Cassie. Would a fine-tuned LLM classification model improve latency, or is it only to improve responses to your specific task? So are these smaller models going to be faster?
Some of them are. The real kind of latency makeup that like is most consistent is we talked about like as you keep adding examples and your prompt gets so long that it doesn't fit in your context window. When you move all of that into the model and then your prompt is just input and like system message, you only respond with emojis. Shorter message, lower latency.
Oh,
Uh,
okay.
some models will have lower latency. Like I think Babbage and DaVinci are going to have lower latency than Turbo, and so swapping one for the other also has improvements. But it's one of those like we can't guarantee it. There's just some like general rules.
I see. Well, as you can hear, that is my walk-off music because we are done with the show. Alicia, it has been a pleasure talking with you, my friend.
Thank you for having me. This was a lot of fun.
Absolutely. Hopefully, we'll have you on another time so you can answer questions about this because this is a very hot topic right now. People are like, I don't know about you, but I am hearing like really awesome questions that kind of are close to the right thing, but needs a little bit of adjustment. So you've adjusted a little bit what I thought. So that's very helpful. Thank you.
I fine-tuned your thinking.
Yes,
Fine-tuning.
that's a good way to end. We'll see you later, Alicia.
Bye.
Alrighty, my friends. This has been awesome. I've learned a lot from Alicia. She is the best. So as we finish up, I just want to let you know that the next show that is coming up is with none other than the amazing Sarah Bird. We're going to be talking about content safety more in depth with her next time. And she's the kind that's like, I'll just show up and we'll do it live. So it's going to be a little bit similar to what we had today, which I think is fun. I don't know. I like seeing behind the scenes of things. So we're grateful to all of you that were able to come. As always, it's a privilege and a pleasure to spend even just a minute with you. It's always fun to learn about this stuff. And if there's any shows that you'd like us to do, or you have something interesting that you've done with this technology, I'd love to have you on. You can talk to us. We can get you on board. But as always, thank you so much for watching. And hopefully, we'll see you next time. See you next week, my friends.